please go to the page titled Adding and Subtracting Polynomials. I'm not showing you the top of this because there's a warm-up up there that I don't want to give the answer away to. We will do that when we come into class tomorrow morning while I check the homework. But again, I don't want to show the answer to it right now. So just find this page right here. Pause the video if necessary until you get to that page. Exercise 1, letter A. How many quarters, nickels, and pennies are needed to make $1.13? You usually start with your highest value and you work your way down. So for quarters, if I start counting, I need 25, 70, 25, 50, 75, $1. And then I would do $1.25, but that's too much. So I need $1 worth of quarters, which is 4 quarters. And now with the nickels, it goes 5, 10, 15. 15's too much, so I only need 2 nickels. And then I need 3 more cents, so that'll give me 3 pennies. So you can kind of see how I did that there. Fill in the blanks for letter B. I'm just breaking down 8,943, kind of how I broke down the quarters, nickels, and pennies. All right. I know I need 8 1,000s, 9 100s, 4 10s, and 3 1s. I could just write that a different way. 1,000 is the same as 10 cubed. 100 is the same as 10 squared. 10 is just 10 and 1 is just 1. And it's still 8, 9, 4, 3. For letter C, again filling in the blanks. I don't walk you through it this time. Notice it says times 20 cubed. 20 cubed is 2,000. 20 squared is 200. And then you have a 20 and a 1. So you need 4 2,000s to get 8,000. And then you need 4 200s to get 800. Okay, so that's going to give you 800. If you did 5 200s, it would be 1,000, and that's too much. So at this point, you have 143 left. Make yourself a little note. From that 143, you can use 7 20s. Okay, because 7 20s is 140. This is a little note to yourself, that's 140. So you know you've got 3 left, so you need 3 1s. So the way I did B and C was very similar how I did the quarters, nickels, and pennies question. You can ignore this little homework note over here. That was just to remind myself I needed to make an assignment for you guys to do. Letter D, just the same way with 113. 5 squared is 25. And then you have a 5 and a 1. So for 25, you need 4 25s, because that'll be 100. You need 2 5s for the 10, and then you need 3 1s for the 3. This letter D is the same exact question as the pennies, nickels, and quarters question that we had. Okay, realize it's the same number, except instead of money, we're talking about numbers instead. Exercise 2. Let's be as general as possible by not identifying which base we are in. Just call the base X. Alright, so instead of having a base of 5 or a base of 10 or a base of 20, our base is now X. We have this expression now instead. You know, something to the 3rd power, something squared, or like this one was a 5 squared, an X value, like this was just a 5, and then we have a times 1. I could rewrite this as x cubed plus 2x squared plus 7x plus 3. It's just a little bit a cleaner way than having it written like this. What is the value of x is 10? Meaning, what's the value if your base is 10? Well, what you do is you plug a 10 in for x. And this is my expression I used right here. So it's 1 times 10 cubed plus 2 times 10 squared plus 7 times 10 plus 3 times 1. Remember, 10 cubed is 1,000. 10 squared is 100. Times 2 is 200. 10 times 7 is 70. 3 times 1 is 3. You add it up, you get 1,273. Letter B. Now what happens if your base is 20? Same exact problem, except plug in a 20 instead. It looks like I made a little mistake here, so we'll fix this as we go along. 20 cubed is 8,000. 20 squared is 400. Times 2 is 800. And this is where I made the mistake. You went back and used a 10 instead of a 20, so please fix that. 7 times 20 is 140. and then plus 3. So I'm going to have to fix my answer as well. My answer will be 8,943 instead. We have some vocabulary that we need to define a little bit. So when we're talking, we can use the right vocab words. A monomial is a polynomial expression generated by using the multiplication operator only. It cannot contain plus or minus operators, or addition or subtraction. Monomials are written with numerical factors multiplied together by a variable or other symbols each occurring one time, using exponents to condense multiple instances of the same variable. So some examples we have, something like this right here. No, all combined multiplication. It's got numbers and variables. What else was I going to say? There's no addition or subtraction. Same thing with this one. You're allowed to have fractions. Same thing here. 2 multiplication pieces, which I would just multiply out to this right here. Because you notice how it said the symbols are occurring one time? Well, this I'd have to multiply to see that A only occurred once, B only occurred once, C only occurred once, and the numbers multiply to 2/5. A polynomial, on the other hand, is a sum or difference of monomials. So if I have monomials that I add or subtract together, that's a polynomial. Mono means one, poly means multiple. The degree of a monomial of these types up here is the sum of the exponents of the variable symbols. So if I have this monomial, if I add up the powers or the exponents, I get 10. So the degree of that monomial is 10. If I add them up here, it's 5. Okay, you might only see the 3, but remember the B has a 1 and the C has a 1, and then that equals 5. The degree of a polynomial, on the other hand, is only the degree of the monomial term with the highest degree. So if I look, this particular one right here has a degree of 2 because the highest degree of the 3 monomials is 2. This one here, the highest degree is going to be this monomial right here. And the degree of this monomial is 9 because you have 1 on the x, 1 on the y, and 7 on the z. Moving on to page 3. We are going to skip exercise 3a. 3b says, what is the value of 22x plus 3 when x equals 5? Well, you just plug a 5 in for the problem. So 22 times 5 plus 3 equals 113. This is you might think this part of the question has nothing to do with the first part, but it's actually the same question. How much money does 22 nickels and 3 pennies make? Well, 22 nickels are worth 5 cents apiece, and 3 pennies are worth 1 cent apiece. When you add that up, that's $1.13. Okay? And that's the same as 22 times 5 plus 3. 3c, what number is represented by that polynomial if x is equal to 10? It's asking you just to plug a 10 in for x. So when you do that, you get 572. Letter D, what number is represented by 4x squared plus 17x plus 2 if x equals negative 2? Or I'm just going to say that if x equals 2 there, I don't know what that was supposed to be. Again, you are plugging in a 2 and a negative 2. So when I plug in a negative 2, I'm going to do it carefully. Negative 2, I square it first to get 4, times 4 is 16. And then 17 times negative 2 is negative 34, and then you have plus 2. So that's negative 16. When I plug in a 2, I end up getting 52 because that becomes a plus 34 instead. We're going to skip letter E. Exercise 4, find the sum or difference by combining the parts that are alike. Tell the degree of the polynomial. So I have 417 plus 231. For this 417, I have 4 hundreds, 1 10, and 7 ones. For the 231, I have 2 hundreds, 3 tens, and 1 1. When I add it up, I have 6 hundreds, 4 tens, and 8 ones. I can do that with the polynomial as well. When I add these terms up here, I combine like terms. I have 6 x squareds. I have 4 x's. And I have 8 for the constant. And I wrote down as the second degree, and it is the second degree because my highest monomial has the second power on it. Finally, page 4. Letter C, same idea. Okay, I have 2 hundreds, 3 tens, 5 ones, and I am subtracting 100, 2 tens, and 5 ones. I end up getting 100, 1 10, and 0 ones. I can do the same thing for letter D. What I chose to do to make it easier to see is I distributed that negative into the entire set of parentheses first, and I rewrote it. So rewriting the first term, I kept it the same. For the second term, you change all of the signs. So negative x cubed, negative 5x squared, negative 4x, and a plus 7. And then you combine like terms. You have 2x cubes. You have negative 6x squareds. You have just a negative 4x, and then you have 15 for the constant. Same thing for letter E. Notice I did distribute the negative 2 first. So I have negative, oh, looks like I made a mistake there as well. X cubed minus 2x cubed is a negative 1x cubed. 8x is just 8x, and then negative 24. Letter F. I'm almost done. F and G. Letter F, I have, and it's just addition. So I have negative t squared plus t squared is 0. Then I have negative t plus 9t is 8t, and then 5. I wrote it in order from highest power to lowest power. For letter G, I rewrote it after I distributed the negative, so I had a 3p plus 1, I had a p minus 8, and then I had minus p minus 2. 3p plus p is 4p, minus p is 3p. 1 minus 8 is negative 7, minus 2 is negative 9, so 3p minus 9. At this point, you just show me tomorrow morning that you completed everything in the video, and then while I'm doing checking the homework, you can do the do now problem.